Je commence?
Assalamu alaikum. It's my honor to introduce our speaker, Mr. Mohammed Amin Ziyan. He is currently head of technology watch unit in Algeria Telecom. He worked in many positions and different engineering domains in telecommunications. He served as a representative of Algeria Telecom at the Ministry of Posts and Telecommunications, ITU community for more than 7 years. He has engaged in a variety of standardization activities. He has also served as African Telecommunications Union expert. He is also serving as board member of World Broadband Association, representing Algeria Telecom. Mohammed Amin holds a state engineering in electronics diploma and a master business administration MBA. Today he will present a presentation entitled Telecommunications Infrastructures in Algeria, Achievements and Perspectives.
Okay, thank you for the introduction. I just want first to thank the University of Guelma, 8th of May 1945 for the invitation, and also particularly the Telecommunications Institute for the invitation. So I just want to transfer on behalf of the CEO the thanks. So my presentation will focus on the achievement of the Algeria Telecom, mainly on infrastructure development. So we will see a number of things related to infrastructure and telecommunication infrastructure in general here. So the presentation will be framed across a number of areas. In any telecom network you can find an access network, transport and international network, and also we are going to see the achievement of the company on the corporate level, what we have been doing many years in this area, and finally some brief perspectives for you, for all of us to consider. And so the role of the Algeria Telecom is mainly around deploying infrastructure and of course contributing to the digitization of the country, right? So today broadband infrastructure is very key and is important, and so in doing so the company need to deploy a certain number of layers of infrastructure. On the left hand side you can see that we need to deploy optical submarine cables that are based on single mode fibers, for those who are familiar with optical communications. So we have international submarine networks that connect the country to the international world. More than 99% of the internet traffic today is crossing across optical submarine cables. Then we have terrestrial networks. We need to deploy terrestrial networks. Then we have another types of networks that we also deploy, core networks, mostly based on IP, Ethernet, for those of you again who are familiar with Ethernet and IP networks. And so at the end we deploy access to connect subscribers to the network. And then we have different types of access networks. We have radio-based access networks, for example, LTE 4G, and then we have PON-based networks, passive optical networks, GPON, and then we have also copper-based networks, which are based on XDSL, ADSL, VDSL types of infrastructures. And so just to remind you the progress being made, and these are the access networks in Algeria, and particularly in Algeria Telecom, went through a couple of evolutions since the 80s, where you remember the public switch telephone networks, which is the first let's say, generation of digital switched telephony, where we have introduced the first digital switch telephony based on pulse code modulation, PCM, for example, and using the voice band, based on 64 kilobits per second, line rates. Then we progressively moved towards deploying wireless local loops based on CDMA, coarse division multiple access, and also the evolution data optimized for internet access. Then we moved in the beginning of the years of 2000 with the integration of the internet with the public switch telephone network. So new and innovative approach in the industry have been also brought to leverage the existing infrastructure in allowing internet access. Then another phase, we have started to introduce the next generation networks, the NGN, which is an ITU, an International Telecom Union concept and standard that come to the architecture of Algeria Telecom in order to migrate from the legacy copper-based, let's say, and public switch telephone networks in order to bring more convergence in terms of services, internet access, telephony, and these lines, fax over IP, and etc. So these are the beginning of introduction of NGNs into the networks. And then the NGN has also been evolved towards introducing ADSL 2+ standards, and then afterwards VDSL, very high-speed digital subscriber lines, which is also an ITU standard. And so all of these evolutions have focused to increase capacity. So these achievement were with the objective of achieving higher capacity for internet access. And so in recent years, from 2017, we have started to migrate to GPON-based standards and GPON-based infrastructure, which is the fiber to the home technology. So we have introduced the first proof of concept in 2017. Since then, the evolution of fiber to the home subscribers have grown significantly from 2018 to 2024 towards 1 million, roughly 600,000 subscribers. And then we have the number of optical distribution network access that we have, which is roughly more than 3,600,000 access of optical distribution network for access to subscribers. So the trends towards moving from PSTN to fiber-based infrastructure, you can see it on the top. So you can see that the copper-based infrastructure have been in decline since 2016. So in order to move towards more fiber-based infrastructure, FTTH, fiber to the home, and you can see the rise of the subscribers till 2024. And so the fiber-based infrastructure is very important for any digital economy. So we will see much details on the fiber-based infrastructure. Of course, there are challenges from the company to deploy this kind of infrastructure. So the modernization is very, is heavy in terms of the investment. So from the investment side, it is important. So improving quality of service, this is also a focus from our side in order to move from legacy infrastructure towards more modernized infrastructure. And then we are also focusing and looking to more advanced infrastructure based on XGS PON, which is 10 gigabit symmetric PON in the near future. So to illustrate the speed that have been resulting from this modernization and improvement have been really felt across the recent years. So we recently launched the offering of 1 gigabit per second to subscribers, and then another effort in terms of affordability of prices, which really there was significant effort in terms of guaranteeing more affordable internet access prices for gigabit access. So the GPON is an ITU standard, is an ITU-T standard, which is G.984. So you can see that this is the architecture of the entire network. On the left-hand side, you can see the GPON access, the OLT access node, which is connected to multiple ONTs and ONUs that use splitter inside the optical distribution network. We have also coexistent elements in the CE here, which used for connecting other newer PON system in order to coexist with the legacy one. So the traditional system theoretical reach is 20 kilometer using the ODN, optical distribution network, in order to achieve 2.5 gigabits in the downstream and 125 gigabits in the upstream as capacity. The next rate is 10 gigabit symmetric PON systems, which is also another ITU standard, G9807, which is higher order capacity, which also allows subscribers to move towards higher speeds. So it leverages an existing ODS, which is based on splitters and coexisting elements. You can see that on the bottom, you can hear that there is the legacy GPON, which is being integrated with new generation of GPON, 10 gigabit symmetric PON using coexistent elements, and these are splitters in order to use the fiber in order to split the capacity towards the subscribers, and it uses TDMA as technology, so time division multiple access for the downstream for users. And you can see that the technology allows the use of voice, data, and mini services. The coexistent elements that allow us to coexist with next generation PON OLT, which is optical line terminal, and legacy PON OLT is the coexistent elements. There are many research underway on these topics, particularly for higher speed, 50 gig PON, 100 gigabit PON, where the main challenges for operators are how can we leverage existing infrastructure, meaning the existing optical distribution network, and you can add, higher speed access nodes in the end side of the network. And so these are, and so we can the research currently is on how can the network behave in going into higher speed, and what modulation formats are we going to use, and which latency are we going to tolerate, etc. So all of these, this standard is an ITU standard. Is very important for operator to consider coexistence with multiple technologies over the same network. For the access networks, another important trend that we have seen is that the rise of 5G front haul using passive optical context. You can see that the 5G stack here, RRC, PDCP, and all the 3GPP 5G stack has been split. So it gave rise to front haul and back haul portion of the 5G network. And so the current research in ITU is that how can we leverage upon passive optical network as a backhaul. So there are many scenarios that we can envision So this is also an important from operator perspective and also from research perspective. How can we transport? So these are opportunities for access network to leverage in terms of transporting 5G data across the network. And so for the transport network, it is important to accommodate the access network traffic. So the transport network for Algeria Telecom is really an important segment. So we have more than 147,000 kilometers of optical fiber being deployed, mainly single mode fibers based on G652 standard. So you can see how over the years the efforts of deploying optical fibers across the country. And so the transport network is as I mentioned earlier, is composed from number of submarine cables. So the Algeria is connected to the worlds through number of submarine cables from Oran, Algiers, Bijaya, and Annaba. 4 submarine cables that you can see on the screen, and then we have terrestrial link linking Algeria to Tunisia, and then there is a future project where we can consider joining new submarine cables or consortia of submarine cables in the future, like Africa 1. Capacities of this, the network of Algeria Telecom uses in transport DWDM technologies, which is based on wavelength multiplexing, right? So in order to increase capacity, we use DWDM for dense WDM technology. So I'm going to switch here and then go back to the capacity. So you can see the territory of Algeria in that way, and all the green are the optical fiber links that link all the territory. So in 2023, the network is composed of rings, of DWDM rings across the country. So you can see how the capacity was in 2023. In most of the rings, 2.2 terabits in north east, at 3.15 terabits. So T is terabits. And these capacity, of course, have evolved over time to achieve. In some areas, the capacity has doubled to reach, for example, in the northwest, 2.2 terabits, moved towards 2.6 terabit in September 2024, and we are foreseeing by the end of this year to achieve 3.6 terabits per second in these regions. And of course, the network is using ITU-T standard G8131 on sub-network connection protection, and also automatically switched optical network. These 2 protocols are allowing the network to add some intelligence at the optical layer, and so ASON is widely used in most operators for automatic switching, and it leverages also MPLS-TP, so multi-protocol label switching for transport profile. So here I just want to show you these. So these capacities, as I showed in previous slides, demonstrate clearly the achievement and the continuous increasing of the bandwidth and of the DWDM rings across the country. And so the submarine cables, as I mentioned, are very robust systems. So you can see each and every submarine cable, optical submarine system has its own capacity. So you have the the potential capacity, the equipped capacity, and the exploited capacity. So the potential is how much the system can have as switching backplane, as total switching capacity. And then the equipped capacity is how much capacity you have equipped as boards that they are included into the equipment, and how much you are exploiting on this. So you can see that the most used system is the one linking Algeria to Valencia, which is Arval, which has the 26 terabits of potential capacity. So the numbers are in gigabits per second. And so the next link is the terrestrial connectivity link in Tunisia. You can see the capacities. And so the total submarine, optical submarine cables capacities is in the bottom. So the potential capacity is more than 32 terabits per second. So it's important to guarantee enough capacity for Algeria. This is just another illustrative figure to see how much progress has been made in terms of international bandwidth capacity. So from 2020 towards 2025, the capacity has greatly increased in total due to heavy investment in optical submarine cable systems. The transport network, the company has also microwaves for transport network. So we use a number of different types of frequency bands in terms of microwave transport from 6 gigahertz to 8, 11, 15, 18, 23 gigahertz, and also the E-band 71, 76. All of these bands are in accordance with I2R standards. You can see all the recommendations on the right-hand side. All of the microwave links, we have more than 21,000 kilometers of microwave network across the country. And you can see on the bottom the usage of each and every frequency according to the distances, right? So we have the less used, the most used frequency in accordance to the distance is the E-band, and the 6 and 8 and 11, and the oldest 15 are used for longer distances across longer line of sight or long haul applications. Another portion of transport is the IP network. The Algeria Telecom heavily invested recent years in order to increase internet connectivity and IP network. So all the networks is composed of layered infrastructure. You can see on the bottom that we have access networks composed from multi-service access node, GPON OLTs, Wi-Fi, WiMAX. WiMAX is no longer existing, but we have LTE, long-term evolution, and any type of network is being connected to another layer of aggregation, which is the metro area. So we call it metropolitan areas network, which is based on Ethernet, which is using carrier Ethernet networks, and so the metro area is then connected to more robust transport network of IP/MPLS, which is another global national backbone, which then connected to the outside world. We are going to see these aspects particularly in the next slide. You can see that we also, in order to decrease international capacity, we are using cache servers nationally. So Google and Facebook and many others are being deployed at national levels across the areas in the countries in order to decrease the international bandwidth usage. So this is a strategy that is fruitful, let's say, for the company. So let's start with the metro area, right? So we are in the IP transport. Let's start with the metro layer. So the metro layer is based on Ethernet protocol. So Ethernet has been widely considered for many operators due to its effectiveness, cost reduction, and many advantages. So the metro area has gone through a number of, from architecture perspective, it has gone through many evolutions. So you can see the topology of the metro area in 2014. So we had a simple 10 gigabits capacity across the links here. These are switches that perform layer 2 and layer 3, and which are connected to higher capacity routers and broadband network gateways. And so initially the topology was based on 10 gigabits capacity, 10 gigabit Ethernet. Then we moved towards, in 2016, towards higher capacity, 40 gigabits Ethernet types of links. Then we moved in since 2020 in the introduction of 100 gigabits Ethernet links at the metro area. And you can see that the network, since its evolution, is considering more rings in order to have more protection and restoration for the networks. That's guaranteed availability and resiliency for the network. Then we move to the backbone. The metro are connected to much more bigger infrastructure, the backbone. So you can see here, imagine that these are the metros areas that we were talking about, which are connected to a bigger backbone with bigger routers that contains higher capacity. So the backbone is based on IP MPLS. MPLS is an IETF standard, so it's multi protocol label switching. So we use label switching for fast switching across the network. And so initially from the period 2010 to 2014, the core network was based on STM16. So STM is SDH standard for those of you who are familiar with synchronous digital hierarchy. So STM16 is 2.5 gigabits. So it was really very low capacity, and so the network has evolved from 2014 to 2018 in integrating 40 gigabit. So it's a mix of 10. So we moved from STM16 SDH based on 2.5 gigabits towards 10 gigabits and 40 gigabits links. So it's a mixture of these two capacities. And so there is also an extension of geography. So we in addition to this, we have explored new geographical zones across the country to cover these areas. Then from 2019 towards today, the backbone has really greatly evolved. So based on OSPF and BGP protocols, segment routing, and all these networking standards. So we move from full N times 100 gigabits, so it's 200 gigabits and etc. in the core. So this has been resulted in densification and extension of transport network. You can see that from 2013 towards 2024, we have moved from 500 nodes. These are the number of nodes that are routers and metro nodes. So at the same time, these are the number of nodes across the metro and the backbone. So we moved from 500 nodes, both of the layers, from 2013 towards 3,500 nodes in 2014, just to show you the significance of the evolution of transport network in order to accommodate high volume of traffic, of internet traffic, and all traffic flows across Algeria Telecom. Layer of international gateways, we call them international gateways. So the international gateways, so this is the backbone that we are seeing earlier. This is the axis and then the backbone and the metro. This layer is also facing another layer of composed of IGW is international gateways, and they have similar architecture to face the internet on top. So imagine that you have all the players, Facebook, Google, and the Orange, and all the carriers internationally. So we also deploy some sort of international gateways networks as follows, based on IP and MPLS also. So this network also has evolved from its point of presence. We have 3 points of presence, 4 points of presence across the country. We have in Algiers, Annaba and Oran, and also in Tamarasset. All the capacities of these point of presence, as you can see, 20 terabit for Algiers, 30 terabit for Annaba, and 7 terabit for Oran, and 1 terabit in Tamarasset. They are all based on vendors like Juniper, based on MX 2020 routers, and also Huawei NE9000, which are very great and big routers for big capacity, for interfacing with international networks, for peering and transit. Then, so the international network has the responsibility to undertake peering with other international networks. So peering is a BGP sessions that you can set up with other international networks in order to exchange internet traffic and routing information. So this is important for any service provider. So you can see how the peering and transit is how much international traffic you are getting to flow across your network. And so this traffic is being paid for the operators that flow your traffic upon your network. So you can see how much the IP transit have been evolving, and also versus the peering traffic. As I said, there are a number of cache servers that have been deployed, and what we call these are content development networks. So CDNs, or content delivery networks. So CDNs are like the Netflix, the YouTube, and all these over-the-top OTTs providers. So if you host a CDN in your country, you are going to achieve lower latency. So one of the things is really how to reduce not only internet traffic, not only reducing international bandwidth, so you save bandwidth internationally, but also you reduce latency. So servers who are in the United States, the ones who are hosted in your country, there is big difference in terms of achieving latency. And so this kind of traffic is getting importance. So 55% of the internet traffic is served by these kind of servers implemented across the country. So this is how the cache servers are being deployed across the country. So these are small Google cache servers. You have here Tlemcen, Oran here, Algiers, and across. They are connected towards the switches, and then the IPMPLS provider edge routers. This is an example of how Google cache servers are being deployed, and so you can see the capacity is of 1.8 terabits nationwide. Also, Facebook cache is also deployed. You can see how all the cache servers of Facebook Facebook is being consumed huge capacity for internet, for international bandwidth. That's what the decision is, to bring cache servers nationally in order to increase, reduce latency and decrease the international internet bandwidth consumption. So MNA is Meta. Meta is Meta appliances are being deployed at Algeria Telecom. So the agreement was signed in 2021. Other CDNs are planning to be deployed in order to reduce the latency and international bandwidth, like Netflix, Cloudflare, and maybe in the future TikTok, Tencent, and other content delivery networks. So the IP network is evolving, and there are a number of new techniques that allow us to introduce automation into the network. Software-defined networking is one of the things that we have really introduced in order to bring automation on how we make provisioning of the network, how can we do maintenance, or undertake policy on the network, and also orchestration. So there are also orchestration devices that allow us to have an end-to-end visibility across the network. Now, the corporate segment is the segment which we focus on serving the enterprises. So it's the enterprise segment, and so the enterprise segment is the segment where you focus on SMEs and big corporation in Algeria, and how can you provide value-added services to the corporate segment. So the services are diverse for this segment. So internet access, collaboration tools. So so some sort of collaboration solutions like video conferencing, voice over IP solutions, and etc. IT integration, consulting, and also cybersecurity services. For example, there are a number of projects that Algeria Telecom has achieved with the digitization project with the High Commission for Digitization. And so Algeria Telecom was the partner in terms of the digital transformation strategy of High Commission of Digitization, by providing connecting the data centers and providing connectivity solution. And so there are services that have been introduced, like software-defined WAN, which is an SDN-based approach, and also the introduction of IT security solutions for this project. The digitalization of the financial sector, another achievement, is also based on providing connectivity. So interconnection of data center facilities for the Ministry of Finance is being planned in order to allow them to automate data collection for the financial sector, and also roughly 400 sites for the national domain. The general director of the national domain were connected. Also 200 sites with advanced connectivity for the Algerian customs, and also the Directorate of Accounting. Nearly 60 sites, and many more sites are being connected in order to allow digitalization of the financial sector. Also, the banking sector is benefiting from advanced connectivity and services, and so you can see that banks have benefited from the establishment of their private network, VPN network, based on MPLS VPNs, and also links for the modernization of SATIMs, for example, central site, and to include redundancy, but also the integration of IT solutions for example, geo-monetic electronic money. So we also have services on the IT segment. Some numbers for the banking sector and the contribution for digitalization, the digitalization of the banking sector. So number of banks, nearly 3,000 sites connected to optical fiber. For insurance companies, you can see that roughly 2,200 sites connected by optical fiber. Also the post services and Algeria Post also are all connected by fiber. The public administrations also they are undertaking massive digitalization. The Algeria Telecom is playing a central role in facilitating connectivity of many municipalities, dairas, wilayas through internet network and also via fiber optic links. The health and health establishment also benefits from the deployment of their local area networks infrastructure. For example, university hospitals, CHU, healthcare institutions, which they are greatly benefiting from fiber optics. Also, schools are very important in terms of connecting schools to the internet access. Some numbers with regard to the modernization of public administrations. So all the MICLAT, Ministry of Interior, you can see that number of sites are being connected to the optical fiber. Also the healthcare industry or healthcare sector, more than or nearly 2,000 accesses via multiple technologies. They may have VDSL or fiber-based infrastructure. And finally, education sector with more than 2,300,000 accesses connected. The health sector, I think I've talked about this. The education also. So, for example, the education sector, the creation of an IP and PLS intranet network via fiber optic media, and also universities and also other training institutions. The segment in education, the progress in education sector, briefly as numbers, as you can see. So number of sites also are being connected for l'Office National de la Formation à Distance. 32 sites connected by fiber, and also universities and training and higher education establishment with a number of sites being connected to fiber infrastructure. Another key pillar is hosting services. So hosting is, is some cloud-based offering to the SMEs who want to host their servers or host their website. So the company is also offering these services with reliable, advanced high-speed connectivity, and also security systems with guaranteed redundancy. So we leverage Algeria Telecom data centers into that segment in order to provide services. Another segment is contribution to the digitalization of political events, cultural and sports events. So the company is really heavily in terms of providing innovative services. For example, the modernization of sports infrastructure through the deployment of Wi-Fi networks, Wi-Fi 6 for instance, when it comes to big sports events like les Jeux Méditerranéens, as an example, the Mediterranean Games. Also hosting for sports application, like for example that Gerati is being hosted by Algeria Telecom. The connectivity for various venues and events like fairs, exhibition halls, and etc. So and you can see an examples of the sports support for sports events, like as I said, Mediterranean Games in 2023, the Shan and Pan-Arab Games, deployment of connectivity and Wi-Fi solutions, mainly on Wi-Fi 6 for gigabit access. And also the allowing the health sector for live broadcasting of surgical interventions, for example, in CHU of Tizi Ouzou and CHU of Nafisa Hamoud. There are new services because there are demands, so new services of Algeria Telecom, wide range of services from IP telephony, and also call center solutions using leveraging the NGN network. Modular data centers. Now data centers are being modular, so they are sort of small building blocks that are being integrated in order to have much more bigger data center. And also DDoS, distributed denial of service detection and protection. So this is very important cybersecurity package for customers. Audit and advice for implementation and end-to-end solutions being provided. Technical assistance is also being provided to enterprises in terms of maintenance of their the technical installation and facility, management of network equipment, etc. I want to conclude with perspectives. The company is really heavily involved and invested in quality of service projects, and so this is one of the perspectives that the company is looking for in terms of deploying system management of quality internally, and also leveraging much more customer experience and enhancing customer experience. But also there are other technical measures that are being implemented internally. For the access network, so the PON beyond 10 gigabits is, so now we are planning to, in the near future, to undertake move towards 10 gigabits. But the industry, particularly the ITU standard organization, is looking to 100 gigabits in the PON access, and even 200 gigabits through use of various techniques in order to achieve these line rates. So we are paying attention to this standard development organization's work, not only for PON but also for OTN, optical transport network beyond 400 gigabits. Now we are discussing 800 gigabit at the ITU, and also 1.6 terabits capacity is being discussed in research and optical conferences. Fiber to the room is also something that is being introduced at the international level, and something interesting, as maybe we can consider it in the future. So it's like fiber in the internal home. So many research are on this particular domain, integrating cloud technologies and services in FTTR. AI, I saw a very interesting contribution earlier on artificial intelligence. So we are thinking to introduce artificial intelligence in network management, in maintenance, predictive analytics, predictive maintenance, and forecasting. So large language models are important in telecom networks, and this is really the trends and the future. It's now. So the perspective is on AI is really getting more and more attraction. Cybersecurity. So when we speak about digitalization, we cannot ignore cybersecurity. So Algeria Telecom has an entire cyber defense center with a variety of teams undertaking defense and penetration testing purposes. So But again, this pillar is important. So the perspective is on the cybersecurity will be higher, particularly when thinking about 5G deployment, cloud computing, containers-based cloud infrastructure, etc. Sustainability. So sustainability is how can you introduce more reduce carbon footprint equipment, and what are the innovative techniques and technologies that can be envisioned to achieve this. Also, we are paying attention to standard development organizations on this particular topic. There are many techniques in optical networks, how to reduce energy consumption, achieve energy efficiency in the OLT or the ONT or in any node on the network. And finally, I think it is important for us as a company to work with academia in much more ambitious format, so we can benefit from the academia, and academia can benefit from the industry and the network of the company that have and the experience on the industry side. So this is my final interesting point. Thank you.
Thank you very much, Mr. Benzian, for your impactful presentation. Now we invite your questions.
Thank you for your